Alright, welcome to episode 6 of this series. In this episode, I'm going to go over a very basic derivative rule right away, only take like a minute. Then we're going to jump into product rule, which I'm going to prove, and then we're going to do some examples. Just to start off though, I don't know what this is called, but let's say we have we're taking the derivative of, let's say, 2x plus 3x squared. We know that we can split up the derivative into like two different parts, just like distribute it out. But we can also, let's say this is 3x actually. And this is just the derivative of the whole function. Well, what we can do is, with constant terms, it can't be a variable, it can't be a variable that you're deriving with respect to, but if it's a constant term, like this 3, we can actually just factor it out. So let's make this 3x plus x squared. We're taking the derivative of it. What we can actually do is just like bring the 3 out and worry about it later. So we have 3 times d dx of x plus x squared. Then we can distribute the d dx. So we get, it's a little messy, but d dx of x plus d dx of x squared. And this just equals 1, and this is 2x. And we can't forget about this initial 3. So then we distribute the 3 back, we get 3 plus 6x. And if we were to just derive it normally, we'd get the same thing. You can always check your answer. But in general, you can factor out these constant terms. So let's just do one more quick example just to make sure it makes sense. Let's have, I don't know, let's say 2x cubed plus 4x squared plus 2. Plus 8. And we have d dx. Well, what I see right here is we have 2 that goes into all of these. So let's just factor that out. Bring the 2 out. Factor out, distribute the d dx. We got 2 times, it just takes a long time to write out. It's a little messy, my bad. But then this is just 3x squared. This is 4x, and that's just 0. And we still have our 2 from the beginning, and our 2, so then we distribute our 2. We get 6x squared plus 8x plus 0. So that's our final answer. And just to make sure, we look back, see if it makes sense, and it does. But let's get into the main lesson of this video, which is the product rule. And this is, we've done derivatives where we have like two different like parts where it's like x squared plus 3x cubed, or like x squared plus sine of x. But what if they were multiplied by each other? So what if instead we wanted to take the derivative of x squared sine of x? Well, this is a little different because they're multiplied by each other. We can't just distribute the dx and add them. So what we're going to do is, I'm going to prove it real quick. Let's just write it into more basic terms. If we have this main function f of x, and it has two different parts, like from earlier, this x squared, let's just say it's g of x, and that sine of x, let's just say it's h of x. So if we have like two different functions of x, g, h, I don't know, g was x squared, so it'd be like that, and then there was like sine, and there's x on the x-axis. So we just split this up into two different functions, and what we want to do is, as our basic derivative rule, we take the limit of x of x plus delta x subtracted by f of x divided by delta x, and the limit as that approaches 0 is our derivative. So we're going to do that, but first I just want to go over something real quick. So if we have this delta x, and as it gets really small, these like 2 points get put on top of each other. So as delta x gets really small, so does delta g. And the same goes for delta x with respect to delta h. So just keep that in mind. We went over that a little earlier. Let's redefine this into some simpler terms. Let's say y equals f of x. I just like it better this way. We'll have u, actually we'll just say a equals g of x, and b equals h of x. So we can rewrite this as just y equals ab. So now let's do our limit as delta x approaches 0 of f of x plus delta x. Well, that's just going to be, one second, I got a text. That's just going to be, a plus delta a, then b plus delta b minus ab all over delta x. So let me explain where this delta a and delta b comes from. I'm looking at the time we're actually going to have to do an example in a different video, but I'll make sure it's a good long example. But so if we redefine this function, instead of g is just a, then you'll see that delta a and delta x are pretty much equal, because we're this is an infinity, this is 0. Because we're evaluating this as delta x approaches 0, we know that when they're both 0, when delta x approaches 0, so does delta g. So we can set them equal to each other. So, and because f of x is just two functions, then like this corresponds to this part, and that corresponds to that part. And we just multiply them together. hopefully that makes sense. But now, let's FOIL this out. So we got A times B plus delta A times B plus A times delta B, and then delta A times delta B, get a little cramped, minus AB, as from this part, all over delta X. So let's look. These two cancel, it's just positive and negative, and remember that we're taking the limit of this whole thing, so we can distribute our limit just like we did with our d dx. So let's rewrite this a little neater. Then finally, alright, so with our basic derivative rule, let's make some room here. Our basic derivative rule, like as delta x approaches 0, and we take the slope, which is like delta y over delta x, then that just equals dy dx. And that's pretty much what we have right here. And earlier where I said like you can just distribute a constant outside, well this can be our constant, because it's not with respect to x. So we can just say this is b times, instead of dy, this is delta a, so it would just be dA dx times b. And then here we have pretty much the same thing, just in reverse. We add them, we got a times db dx. And then here, we have all of these things. Remember, like, as delta x approaches 0, so does delta a. As delta x approaches 0, so does delta b. B and h are the same thing, as we said earlier. And we have two things approaching 0 multiplied by each other, divided by something also approaching 0. So we're left with like one thing approaching 0 on top, and of course as that approaches 0, it's just 0. So we can say this whole thing just equals 0. And this got really messy real quick. Hopefully as time goes on I'll learn to make things less cramped, but maybe I just need a bigger page. But yeah, let's just move this back up. So the derivative of y equals ab is just b times dA dx plus a times dB dx. And that's our basic notation of it. And we're going to do some examples in the next video. Let me just make this a little more neat. Hopefully that makes sense. I'll see you in the next video where we're going to do some examples. And I'll make sure the examples still have some parts of like chain rule and other stuff for some review.